So this is a complex number. So how we can define complex number? So complex number is defined in this way. If we take an example, like such kind of structure or form 3 plus iota or 2 iota or 4 plus 5 iota, where iota is equal to under root over minus 1, which shows that iota square is equal to minus 1. So such kind of form creates complex number. So we can replace, we can show this in a general form. We can take z, a complex number, in this way, x plus iota y. So here x belongs to real numbers and y also belongs to real numbers, but this part is considered as real part and this part is considered as. So in Cartesian complex plan, here the Cartesian plan is called complex plan. So this is x o x slash, this is y o y slash. So this is called a real line or real part of the complex plan, the complex number, and this part is called complex or imaginary part. So this is the imaginary part. So if we wish to put this complex number z in the complex plan, then z will be in this way, x, y. So this is the abscissa is x and the ordinate is y. So in this way we can present any complex number. Here this distance of the point z from the origin O is represented by OZ, and this is called the modulus of the complex number. So this is called modulus of the complex number z, and the angle formed by this line OZ with the x-axis, if this is angle theta, then theta angle is called amplitude of the complex number z. Amplitude or argument of the complex number z. Now how we can represent through x and y the modulus and the amplitude? So we can take in this way that the modulus is represented by in this way, mod z is equal to, if we take this is a right triangle, then and if the distance is taken r, then r is equal to by Pythagorean theorem, r is equal to under root over x square plus y square. This is the hypotenuse, the base, this is the height. So r is equal to under root over x square plus y square. So mod z is equal to under root over x square plus y square. So this is the form of the modulus, and the amplitude we can represent this in this way. We know that tan theta from this right triangle, we can calculate that tan theta will be y by x. So here theta will be tan inverse y by x. So this form shows that what is the value of amplitude of the complex number z. So in this way we can find out the modulus of the complex number and the amplitude of the complex number. Now we can add two complex number, add or subtract. So if we take z1 is equal to x1 plus iota y1, and z2 is equal to any two complex number here, x2 plus iota y2. So we can add or subtract these both these complex numbers in this way. We can take z, any complex number, is equal to z1 plus z2. So here we have to remember that real part adds real part and imaginary part adds imaginary part. So this will be equal to x plus x1 plus x2 plus iota y1 plus y2. So in this way we can add up or subtract two complex numbers. Also you can multiply two complex numbers, like if z slash is equal to z1 multiply z2, then it will be equal to x1 plus iota y1 x2 plus iota y2. Just to go to the multiplication directly, will be equal to x1 x2 plus, here we will get a real part. If we multiply both of these, we will get iota square, which is equal to minus 1. So this will give us y1 y2 plus, and the other multiplication we will get imaginary parts, iota x1 y2 plus x2 y1. So this is the multiplication of two complex numbers. Also you can divide two complex numbers. Again, if you take z1 is equal to x1 plus iota y1, z2 is equal to x2 plus iota y2, then the division z will be equal to z1 by z2. So for division of two complex number, we have to know that what is the conjugate of any complex number. So conjugate of a complex number of any complex number. If we take any complex number z is equal to x plus iota y, then the conjugate can be written in this way. Conjugate of z equal to, we can write down minus x plus iota y, and another one is x minus iota y. So both conjugate are taken both, so that in the denominator it can, after multiplication, it can replace the imaginary value. It makes the imaginary part a real part. It is the necessity of the conjugate of z. So both these factors, or both this complex number can make the denominator part a real part, from imaginary part to a real part, but we will take this as a conjugate of the complex number. We will not take this. So here, for division, we need the conjugate of the complex number. We will take, and it is denoted by as z bar. So we will take z2 bar, z1 z2 bar. So this will give us x1 plus iota y1, x2 minus iota y2. Here we will get x2 whole square plus y2 whole square, and we will get a square minus b square formula, and we will get a square plus b square. So here we will get after multiplication of the numerator, we will get x1 x2 plus y1 y2 plus iota x1 x2 minus y1 y1 x2 y1 x2, and the denominator will be x2 whole square plus y2 whole square. So here, if we just separate, the real part we will find out, and the imaginary part we will find out. So it is another complex number. So we can follow this after addition, subtraction, multiplication, division of two complex number, we will get another complex number. So addition, subtraction, multiplication and division all are possible, but we will get another complex number. Now we also get the modulus after addition of two complex numbers. So if z we get after addition of two complex numbers z1 and z2, this will be x1 plus x2 plus iota y1 plus y2, then its modulus will be mod of z, it will be under root over x1 plus x2 whole square plus y1 plus y2 whole square, and the amplitude will be, we have to find out in this way. This is z1, this is z2. So its amplitude is theta 1 and its amplitude is theta 2. then the amplitude of Z1 plus Z2 is theta 2 minus theta 1. Theta 2 minus theta 1 tan theta 2 minus theta 1 will be tan theta 2 minus tan theta 1 by 1 plus tan theta 1 tan theta 2, so which gives us tan theta 2 tan theta 1 is y1 by x1, tan theta 2 is y2 by x2, so here we will get y2 by x2 minus y1 by x1, 1 plus y1 by x1, y2 by x2. So after solving we will get just this. x1 y2 minus y1 x2 by x1 y x2 plus y1 y2. So this will be the amplitude of the complex number Z after addition or subtraction of two complex numbers. So you can look this. Thanks for watching.